Okay. This time we got all the formulas up there laid out. Good. This should be easier. Now, we did add another resistor here. So, as you look at this particular circuit, series parallel combination circuit, and I mentioned I always like to start on the right side and then work my way back. Where would be the most, what can we simplify first?
Back up to two parallels.
Can you, which one, which values?
The 40 and the 10.
Now, the 40 and the 10, they are in parallel, but is the 10 in any other relationship with anything else?
Series. All the outer.
The 70 and the 10 first, right? So we can't start by adding the 40 and the 10 because the 70 and the 10 are in series. So our first step, we're going to, and I'm just going to draw this one right here. We're going to add that 70 ohm resistor and that 10 ohm resistor, and then just redraw our circuit one more time. So the 50 we didn't do nothing with. 40 we didn't do nothing. 30 we didn't do nothing, but we did combine that 70 and the 10, which brought us up to 80 ohms. I'm going to write all my R, E, I, and P for everything. And our voltage didn't change, we just simplified our circuit. Now, we took care of adding the 70 ohm and the 10 ohm. That gave us this 80 ohm resistor. So next step, we're going to combine which ones? Which ones?
40 and 80.
The parallel, right? Because I can't add this 50 to anything because they're in their own relationship right now. Same thing, I can't add this 30 to anything up here because they're in their own relationship. Next step, add the 40 and the 80. I'm going to come up here, so it's going to give me a little bit more room to work. We didn't do nothing with the 50. We didn't do nothing with the 30. But we did add the 40 and the 80. Adding resistors in parallel, there's our formula. So I'm going to just write it over here because it makes it a little bit easier. RT equals 1 over 1 over 40 plus 1 over 80. And I'm going to have to convert it back to decimals again. So 1 divided by 40 equals 0.025. 1 divided by 80 equals 0.013. And the 0.013 is rounded because it would have been 0.0125. But to take everything to just to the thousandth and display it, we round that to a 0.13. Add those together. And we end up with 0.038 here equals 0.038. 1 over 0.038, 1 divided by 0.038, and we end up with 26.316. So right here, my ohm value, I'm going to draw it on the inside because I ran out of room, 26.316, and that's my R. And I always go R, E, I, and P. That's just the way I've always done it, so I'm just sticking with what I've always done. So I have a 50 ohm resistor, 26.316 ohm resistor, and a 30 ohm resistor. Those are all in which configuration? Series. So then, if we're going to add them in series, add that formula, right? So now this is going to get us all of our totals. So we had the 50 plus 26.316, that resistor, plus the 30 ohm resistor, and we end up with 106.316, and that's going to be my RT. The voltages have never changed. We've been just working on simplifying the resistors. So the voltage supplied to our circuit simply comes over here. Now we're looking for I. E divided by R equals I. So for I, we take our 120 divided by 106.316. 120 divided by 106.316. And we end up with a current of 1.129 rounded. And finally, P equals I times Z, Watt's law. I is 1.129 times E of 120. And we end up with a total wattage of 135.48 ohms. So that's how we found our P. And this is how we found our I. E came across, and then we added the resistance together to get the RT.
I'm sorry.
Yes, sir.
How did you get the 106.316?
50 plus 26.316 plus the 30, which would be this formula right here, the RT for the series circuits.
Okay.
Now, once you've got to your totals, you just start working your way backwards, applying whatever rule that for the circuit that you simplified. So this represents this circuit. That circuit is in what configuration?
Series.
And what's constant in the series circuit? The current. So we take the current 1.129 and we drop it at all of these locations. 1.129, 1.129. So now you've got the current that you found in your totals at the current on every resistor for that circuit that you're simplifying. To find the voltage, Ohm's law, E equals I times R. I, 1.129 times 50, and we end up with 56.45. P equals I times Z, Watt's law. I, 1.129 times E, 56.45. 1.129 times 56.45, and we have a wattage of 63.732. And we do the same thing for both of these other resistors. You're looking for E. E equals I times R. I, 1.129 times R, 26.316. 1.129 times 26.316. And we have an E of 29.711 rounded. To find your wattage, P equals I times E. I, 1.129 times E, 29.711. 1.129 times 29.711. And we end up with 33.544 rounded. And then we find our last variables for our last resistor. You're looking for E. E equals I times R. I, 1.129 times R, 30. 1.129 times 30, 33.87. You're looking for P, Watt's law. P equals I times E. I, 1.129 times E, 33.87. 1.129 times 33.87. And we end up with 38.239. Now, at this point, check your work. Because if it's wrong here, it's not going to get any better going the opposite way. This way we can make sure everything's going right. Add our wattages up. So we take 63.732 plus 33.544 plus 38.239. Got 135.515. 135.480. So, boy, we're really close. You know, we're only off by just not even a tenth. Feel pretty good. We can check our voltage. So we got to take 56.45 plus 29.711 plus 33.87, and we should end up to the 120. Let's check our work. 33.87 plus 29.711 plus 56.45, 120.031. We're off by 31 thousandths of a volt. Pretty good. Mine, and remember, we've got just small rounding here. That's why I keep pointing out every time I round it. So I would feel very confident that that's good through that portion. This 30 is this 30. This 50 is this 50. Let's just bring our values over. 56.45. The current 1.129. Wattage 63.732. 33.87, 1.129, 38.239, 38.239. Now, this resistor, this 26.316 ohm resistor, represents those two resistors. Those two resistors are in what configuration? Parallel. And what's constant in the parallel circuit? The voltage. So you take that 29.711 and you drop it at each resistor, 29.711. 29.711. And now you're just back using your formulas. You got to find I. I is E divided by R. E, 29.711 divided by R is going to get us 29.711 divided by 40.743, and that's going to be rounded. P equals I times Z, Watt's law. I 0.743 times E 29.711, and you end up with 22.075.
Say that again, I'm sorry, bro.
No, talk to me, which one?
What was the math on those two again?
To find your I, it's E divided by R. So 29.711 divided by 40 gets you the 0.743. And then Watt's law, P equals I times Z. 0.743 times 29.711 gets you 22.075, and it's rounded. You do the same thing right here to get I. E divided by R, 29.711 divided by 80. So 29.711 divided by 80, and you end up with 0.371 rounded. And then you take P equals I times Z. I 0.371 times E 29.711, and you end up with 11.023. That's rounded. Time to check our work.
When do we divide, or when do we add? Like we divided.
If it depends what you're looking for. If you're trying to find the wattage and you're using for multiplication, because we have I and E, so it would be I 0.371 times E 29.711 to get you 11.023 for your wattage. But to get the I, you have to first take the E divided by R to get I. So 29.711 divided by 80 to get you the I portion of it.
Oh, the formula is on top.
Yep.
Yeah.
So those are pretty much all the formulas you're going to need if you set it up and do it the way that I do it. There's 12 of them on the front cover of the Ohms law chart, but they're all derived from these two formulas right here. And what you could also do, if you're really good with algebra, some of us are, some of us aren't, you can supplement and stick, because it's P equals I times Z, but E equals I times R. That's the same thing as P equals I times R, or, I'm just going to write it here, P equals I squared times R. Because this E equals I times R, so I times I is I squared, and then you have I times R. So it's just playing with the formulas to solve for them. Now, to check your work, we know that if we added the wattage, it all worked originally when we did it here. We got to do the same thing, but I'm going to add the currents up to make sure that my current should add up to the 1.129. So I take 0.743 plus 0.371, and I get 1.114, off by 15 thousandths of 1 amp. That's pretty doggone close to be off by 15 thousandths. Add your wattages together. We should come up to 33.544. 22.075 plus 11.023, 33.098. Not too far off, pretty close. And I'm sure that's going to be in our rounding. Now, you're working backwards. The 50, we have all of our totals. The 40, got all your totals. 30, we have all of our totals. So we'll plug it in our chart. So the voltage here would be 56.45, I 1.129, 63.732, E down here 33.87, 1.129, 38.239. Here's your total for the 40, 29.711, 0.743, 22.075. We've got basically everything solved. We've got one little branch left. Now, this 80 ohm resistor represents what's left?
70 to 10.
The 70 and the 10. And the 70 and the 10 are in what configuration? In series. And what's constant in the series? The current.
Correct.
So you take that 0.371 and you apply it here and right here. And you're back. You got two variables. You just solve for the third one. E equals I times R. I, 0.371. 0.371 times 70. You get 25.97. And I'm trying to find my wattage. P equals I times Z. So 0.371 times 25.97. We end up with 9.635. Same thing, E equals I times R. 0.371 times 10. 3.71. P equals I times Z. 0.371 times 3.71, and we end up with 1.376, rounded. Now that we've got all of our variables solved, we can easily check our work because we have all of our totals over here. I'm going to start by just my wattage. 63.732 plus 38.239 plus 22.075 plus 9.635 plus 1.376 equals 135.057. 135.48. We're off by basically a half of a watt. Virtually nothing. We can add up the voltage here and the voltage here, and it should come up to that voltage there. So 25.97 plus 3.71, 29.68. That's pretty doggone close to 0.711. What questions do you have about breaking this combination circuit down and solving for solving for it? Any formula questions? Rule questions?
No, the combination.
Combination. Because you have series. Well, this is in series with all this too. And then you've got parallel. So you're just applying those same three rules from the series circuits and from the parallel circuits. You just have to be consistent with whatever you're doing. Ours, because we are rounding them, you do see a little variation because you're cutting off a portion thereof of the numbers. So any last questions, thoughts, or anything to add to it?
You got watts and volts on the last part, correct?
Yes, that way I can check everything. Any step you go, that's the cool thing about leaving all of your work up here. You can literally go to the next picture and then figure out what you can check or what you can't. So like you can't add the volts, you can't add this voltage, this voltage, this voltage, and this voltage because these are the same. So if you added that one, and that one, then you get up here to 120. But if you're going to add the current, that current plus that current is going to equal here or here because that's the same. The current coming in is the same going through. So last questions or anything like that?
I'm still trying to figure out the voltages you added on that last part.